Thank you for the introduction, and good morning. So my team is responsible for putting together two products in particular. As was mentioned, one is BP Statistical Review of World Energy, and we published the latest edition just a couple of weeks ago for those who uses it. And the second product is BP Energy Outlook to 2030. So this year we'll roll over to 2035, but my today's talk is based on still the 2030 energy outlook. And in particular, I want to focus today on two key trends and issues from this outlook. One is energy intensity of economic growth, and the other is pathway of India and China. And in fact, it's these same two issues, the assumptions and views on these two issues that tend to drive differences between many energy outlooks out there. So that's why it's important. But before I do that, and to give you a bit of context, I will briefly kind of take you through our view of how we see the energy world evolving over the next 20 years. So let's start with the very big picture. And on this high level, population and income growth are the two probably most powerful driving forces behind the energy demand growth. And in the next 20 years, we see population rising by about 1.3 billion people, exceeding 8 billion. In the same time, GDP, or world economic output, is expected to roughly double. So what does it mean for energy? The energy falls in between population and GDP. We think it will we expect it to increase by about 36% by the year 2030. And it's in today's developing, industrializing economies where we see the fastest growth of population and income going forward. And even to such an extent that concerns have been raised about whether we'll have enough energy resources to fuel this growth of today's developing economies. This is again why these issues of energy intensity and the pathway of India and China are so important for any global energy outlook. And let's now zoom in on energy a little bit. The first panel shows very clearly where we expect energy to be used, where the growth is taking place, or where it's not taking place. So, and it's clearly that the growth is not taking place in developed countries. That's the OECD there, the dark green area, and OECD stands for Organization for Economic Cooperation and Development. For those who don't know, this is our proxy for developed countries. So their energy demand is pretty much flat or growing very, very slowly, and in fact, in per capita terms, it's declining. So most of the growth is from the developing countries, driven by rising population, rising incomes, and by major industrialization in those countries, and accompanied trends, so the associated trends of urbanization, materialization, and electrification. And in fact, these trends also reflected on how the energy is being used. So that's the middle panel. So the lion's share of growth is taking place, it's the energy used for power generation, for producing electricity, driven by this industrialization. And that's almost 57 or 60% of the total increment in primary energy in the next 20 years. And that's followed by industry, transport, and other sectors. And by fuel, renewables, in fact, are the fastest growing fuel. That's modern renewables, excluding hydro. They're the fastest growing fuel, growing by almost 8% per year, but it's also not hard to see that they're growing from a very low base, and as we've heard, they're still enjoying massive policy support, so it's still not hard to grow at fast rate at this level. And among fossil fuels, we expect gas to be the fastest growing, followed by coal, as those two compete in this biggest sector, power generation. And oil is, in fact, the slowest growing fuel, growing by slower than 1%, so 0.8%. We have the latest number. So by and large, by 2030, we still think that the fuel mix will be about 80% fossil fuels based. And so the last thing I wanted to mention in this introduction is that when we put together this number, so first of all, actually two things I wanted to mention. The first of all, this is our most likely view. This is not a scenario. This is what we think is going to happen, taking into account possible changes in policy and technology. And the second, so when we put these numbers together, the goal is not to get every number right to the last decimal place. So of course, precise numbers are important, but the goal, we know that whatever numbers there will be, whatever numbers we put there, they will be wrong. So that's obvious. So the goal, therefore, is to get major trends and directions right, to be able to see whether some of these trends may be on a collision course, or indeed whether some of those trends may be about to change directions. So with that in mind, let's start with some of these trends. So there are lots of these trends on the supply side and the demand side, and the two of those I will discuss now. It is, of course, coming back to this question of fast growth in developing economies. This is, of course, not the first time in history where we observe rapid periods of industrialization and economic development coupled with the pressure on the known resource base. So the chart here shows the evolution of energy intensity over time, in this case in the UK. And energy intensity is defined as the amount of energy you use per unit of GDP or economic output. So the idea is very simple. The less energy you need to produce a unit of economic output, the more economic growth you can fuel with the same amount of energy. And kind of we put together this huge data set going back as far as 1800, and we've been meaning to make it available on our website, but just we're too busy to do it. And I should mention that all the data I can provide for anybody who wants to use it. So when we look at this historical data, we look back in history, we see that energy intensity follows a common pattern. The pattern is very consistent, and it repeats itself over time across countries and across economic systems. So the pattern, it has a shape of a bell curve or an inverted U, and what it tells you that energy intensity tends to first rise, then peaks, and it declines thereafter. What about the shape? So the shape itself, this inverted U shape, is explained by. So it reflects the very stylized pattern of economic development, and a very well-known pattern of economic development, that is energy intensity tends to rise sharply when countries begin to industrialize, or when the economic structure starts to move away from agriculture-based economies to industrial production-based. So when the industrial production rises very sharply, energy intensity rises sharply as well. And then it peaks and begins to decline more gently, so energy intensity, when the economic structure then moves towards more services-based economies. And indeed, when you look at the evolution of the industrial sector in GDP, it tends to follow in lockstep with this rising and falling share of energy intensity, which suggests that it's the structural transformation of developing economies as the main driver of this pattern, of this shape. So that's as far as the shape is concerned. What about the level? So there are several factors that also determine the level at which energy intensity peaks and the level overall. And the first factor is technology. So the idea is that countries that industrialize later tend to peak at the higher level of energy intensity simply because countries that industrialize later tend to peak at the lower level of energy intensity simply because technology improves over time, and you can take advantage of the more efficient technologies. And an example could be that the modern coal-fired turbines are on the order of 20 times more efficient than the Watt's steam engine. So that's one. And the second determining factor is resource abundance or availability of resources. And it works in the opposite direction from technology. That is, countries where energy resources are more abundant tend to have higher peaks of energy intensity. And that's, again, not hard to see. If resources are more abundant in a country, the energy is then cheaper to use, and therefore there is less incentives to maximize efficiency. So the US here, it peaked higher than the UK, even though it industrialized later, because energy resources are more abundant in the US. And the third factor is economic system. So countries that industrialize under central planning tend to exhibit very high level of energy intensity. And partly that's because resource allocation is not governed properly by the price signals, and also because there is an ideological bias towards heavy industry. Importantly, when the central planning is abolished and markets are allowed to function, the energy intensity, the improvements in energy intensity are very swift and dramatic. So the Soviet Union and Russia here are the case in point. But again, what we wanted to see from all these historical examples, so when we put together this data, is whether past periods of rapid growth and industrialization can help us to understand today's situation. Oh, some more water. And indeed, so it turns out that the same pattern that I described, it still holds true, and holds true for countries that are developing today, so like China and India. And not only that, so there is something new going on, something that we haven't seen before in this past historical data. And this new is that we are now observing convergence in energy intensity between different countries. So all countries, they move in the same direction, they all bring energy intensity down, and they all move closer to each other. I should say that there is one country or one region that is bucking this trend, where energy intensity is still increasing, and that's Middle East. But this is completely a whole and very interesting topic in itself. So besides that, they all move in the same direction. And that's, so what drives this convergence, and for lack of a better word, is globalization. What I mean is that different sources of energy, different fuels are becoming more and more tradable. So they can be used at their most efficient applications. And even the most efficient technologies can be used more and more across borders. And moreover, so even consumption baskets, so the appliances that we use in cars that we buy, are becoming more and more standardized across the world. So from this improvement in energy intensity over the very long horizon plays a major role in our outlook, and in particular in determining the future path of the energy path of today's developing economies. But then there are two of those developing economies which have the potential to change any energy outlook, even in historical terms, relatively short time horizon. And of course, I'm talking about India and China here. And those two countries, so China and India, are on their way to become the world's largest and the third largest economies and energy consumers. And of course, they by far already largest in population size. So we expect them to account by the year 2030 for roughly 35% of population, jointly 35% of economic growth, and 35% of the global economy, of global economic output, and 35% of global energy consumption. And this is all taking place now. So last decade, this decade, and the next. So last decade and the next two. Given gross numbers like that, it is clear that the pathway that India and China take represent a major source of uncertainty. So for any outlook, not only energy outlook, of course. And we kind of boil down this uncertainty to two key questions. And one question is whether China will continue to grow its energy demand as rapidly as it did in the last 10 years, or whether something is going to change and whether this growth will slow or will change its nature. And the second question is whether India, given its population size and potential, can replicate what China did in the past 10 years, and so increase its energy consumption rapidly as its income rises. So these two questions, to answer that, we again look back in history. And it turns out, so the pattern I described, the stylized pattern of economic development, we see at work both in China and India, although they start from very different places. The chart on the left shows the share of industry in GDP. As I described earlier, that's the main contribution, that's the main determinant of the evolution of energy intensity, or how much energy you use per unit of economic output. So the chart, and it shows that, and that's so that share of energy in GDP is set against income level on the horizontal axis. And it shows you that today in China, this share is, the industrial sector is very, very high. So it's high compared to other countries back in history, and it's high compared to other countries today as well. But in fact, the good news is that China is about to embark on this transition, on this structure. It's already on this transition, but right now it's at the top of the industrialization. So, and what it's about to embark on is on the last part of transition, when the economic structure shifts from industrial sector towards more services-based economy. And as it does, not only industry will shrink as a share of GDP, but also the industry itself is going to change significantly, and it's going to change in a way that it's going to change away from heavy energy-intensive subsectors, such as production of steel and cement, to lighter manufacturing. And why is it going to change again? It shouldn't be surprising, but that eventually the need for infrastructure projects and urbanization projects in China is going to decline. So that's China. And on the right-hand side, it shows you how this translates into our forecast for energy demand. So the structural economic transformation in China is going to limit its energy consumption growth quite substantially, especially in the second decade. And especially, so by fuel, that's mostly visible for coal. That would be the main, that would be where the impact is most visible, because coal, of course, is the principal fuel in today's industrialization in China. So that's what fuels in electrification and heavy industry right now. In fact, to such an extent that we think coal consumption in power generation is going to start to decline in China in the second decade of the outlook. And for India, the picture is completely different. India starting from it's still at an early development stage, so still industrialization is still need to progress in India, and infrastructure still need to catch up, and the manufacturing, especially lighter manufacturing, need to expand to absorb India's growing labor force. However, in terms of scale and in terms of composition, we do not think that India will ever reach China's level, and therefore its economy is going to remain significantly less energy intensive, with energy demand growing more gradually in India. So now let's have a look at oil forecast for oil demand. As oil is a little bit different from other fuels, it's mainly driven by the transport sector. And in the transport sector, there's still very little competition. So oil still dominates transport sector. There's still very little competition between other fuels. And so in the developed countries again, oil demand in developed countries has actually peaked in 2005. So you can then say that even economists, even some economists believe in peak oil, even though it's a different concept slightly than was just mentioned before. So oil demand peaked in developed countries, and we think the decline is structural. We think that will continue to decline. So again, growth is driven by developing countries. That's where the growth is taking place of oil demand. And in particular, so one country, China, is projected to contribute about 50% of the total increment in oil consumption in the next 20 years, in the process doubling its own oil consumption. And of course, this is impressive growth numbers. But despite these impressive growth numbers, as you can see on the left there, so in per capita terms, we expect that China's oil consumption is going to remain on a significantly lower path than seen in other fast-growing Asian economies. So to some extent, you can imagine that this is a huge risk, that given population size in China, if they went along the higher path. But to other extent, we think there are some good reasons for that to be the case. So firstly, that China is now facing much higher oil prices, and it's a massive importer of oil consumption. And also, there is a direct government policy in China to limit country's consumption growth. And finally, so last but not least, we expect truly massive improvements in fuel efficiency to take place over the next 20 years. And this fuel efficiency improvement, not only in China, they're taking place. So they're driven by, firstly, consumer reaction to high prices, and by policy, by tightening of policy, such as CAFE standards in the US and the CO2 emission limits in Europe. So overall, so taking those together, we expect that fuel efficiency of the internal combustion engine is going to roughly double over the next 20 years. So this is a huge improvement for a well-known technology as internal combustion engine. And just to summarize in the conclusion, so there is this gap emerging. On the left-hand side, you can see that the gap is between, the first gap is between GDP line and the energy line. And what it means is that until today, we have been able to produce more and more economic well-being with less and less energy. So which means, and our analysis of energy intensity suggests that this trend will continue unabated. So what it means, in other words, is that we should have energy available to fuel this economic growth, and it could be affordable. That is, in the sense that it does not cripple economic growth. So, however, there is the second gap, which hadn't opened up almost at all until today, and that's the gap between energy and CO2 emission. And that puts the question mark on whether the same energy, in addition to being available and affordable, it can also be sustainable. There's some good news and bad news. And the good news is that there is some progress on that direction. So what the right-hand side shows, that's the evolution of the fuel mix as we see it. And what it shows that coal's recent rise in market share is about to reverse, so and start to decline. And this is the direct result of the transition, of the structural transition in China that I just described. And then oil continues on its long run trend of structural decline, increasingly concentrating in sectors where it commands the highest value and can be used more efficiently, as oil is very expensive, as you know. So oil continues to decline, continues to lose market share, concentrating in transport. And if you add to that kind of rising share of gas, as it substitutes coal in power generation, and rising share of renewables, so we can see that there is some slow decarbonization of the fuel mix taking place over the next 20 years. However, this is of course not nearly, and this is not news by now, this is not nearly enough to put the CO2 emissions on a so-called sustainable path of 450 parts per million. And what I wanted to conclude is that this is just to say that we know that we are not on this path right now, and we don't think we will get to this path by 2030. And what we also know that if we wanted to get to this path, that it's not going to be easy and it's not going to be cheap. Thank you.